Question 1. What is the null hypothesis for the significance test comparing two population proportions? Okay, the null is that both proportions are the same. Or for example, if we want to compare the amount of blue M&Ms in a bag to the amount of yellow M&Ms, the proportions, then our null is that they will have the same proportion, that there will be the same amount of blues as there are yellows on average. Question 2. Question 2. What is the formula for a test statistic for testing two population proportions? Explain what each variable stands for in your formula. Okay, so we're still working with the z test statistic. And remember, the z test statistic, the general formula is the value minus the mean divided by the standard deviation. And this is just a little bit more complex as we expand it out to two proportions. So follow along. We're going to start with the p hat for group 1. And remember, p hat is just your x, the number observed, divided by n, your sample total. Or, excuse me, the total that there are. So if you're talking about the M&Ms, it's the number of blue M&Ms divided by the number of total M&Ms, minus your second p hat, which may be yellow M&Ms. And then you're going to subtract your population means of both. So the population mean of blue M&Ms, maybe these are the numbers that M&M company publishes, minus the population proportion of yellows, or the second group, whatever your second group is. Okay, and then on the bottom we're going to have our standard deviation, which again is going to be a long square root of our p hat. Now this is combined, so we combine them both, times 1 minus the p hat times, and then 1 divided by n1 plus 1 divided by n2. Okay? Now these are the sample sizes for each of the groups individually. Okay? And this becomes the formula for the z-test statistic for two population proportions. And it's a good idea to do a few practice problems with these as you go along, and try and remember as much as you can each time you're going through. Question 3. What is the confidence interval for comparing two proportions? Explain what each variable stands for in your formula. Okay, here again we have another long formula for our confidence interval. And we're going to start with, this time we're going to be using our p tildes, which remember is x plus 2 divided by n plus 4. So we'll have our p tilde of group 1 minus our p tilde of group 2, and then plus or minus the z star, which remember for 95% confidence interval, for example, it's 1.96. If you want to review how to find that number, you can go back to lesson 10. So our z star times another square root. And remember, this portion of the confidence interval is called the margin of error. And this is kind of your point estimator, or the sample mean. Okay? So we're going to start with our p tilde of group 1 times p tilde, or 1 minus p tilde of group 1, divided by our sample size of group 1 plus 2. And then also, again, the same thing for the second. P tilde of the second times 1 minus p tilde divided by n, which is the group sample size of your second group, plus 2 as well. And that gives you the confidence interval for your comparing. Remember, the minus, when you do a subtraction, when you subtract, that goes on the left, and when you add, that number goes on the right, and that becomes your confidence interval once you plug that into the calculator. Be real careful around parentheses. a few hints here. It's really important that you have parentheses around these denominators when you're plugging it into the calculator. Some calculators also make sure to include a parenthesis after the square root, after you press the button square root, and then one at the end as well. That should do it for you. Check the requirements. Now remember, if we're doing a hypothesis test of two proportions, our requirements are that n times p, your proportion times your sample size, has to be greater than or equal to 10, as well as n times 1 minus p has got to be greater than or equal to 10 as well. And we'll need to do that for both groups. So we'll start with the women. The women, the n is 296, and then our p, remember, is equal to your x divided by your n, okay? Which is equal to, if you just simplify those across, is equal to 63, and then we check it. Is 63 greater than 10? Yes, it is. Okay, so then let's do n times 1 minus p. So we have 296 times 1 minus 63 divided by 296. Okay, you can plug that into your calculator. It's a small decimal, and you get 27. Or excuse me, you get 233, which is most definitely greater than 10. So that's for the women. So the women check. Now let's try with the men. Okay, so we have 251 men, it looks like. So n, 251, and then times 27 of the men, were label checkers, divided by the total, 251. You can cancel those. And 27 is greater than or equal to 10. That's okay. Then we try it again. 1 minus 27 over 251 is equal to 224. So 224, which is again greater than or equal to 10. So we pass the requirements to do a hypothesis test. Question B, state the null and alternative hypothesis. Okay, so remember from part 1 that your null hypothesis in comparing two proportions is that both proportions will be equal. In this case, that both men and women, an equal proportion, will be label checkers. Part E, compute the test statistic. Let me show you how to do this on Excel. Okay. So if you open up your categorical Excel sheet and make sure to come down here to the two proportions. We're going to be doing the two proportion. We can check out our x and our n for each one using the chart that they gave us. So for our x1, I'll use as women. We had an x of 63, meaning 63 women were label checkers out of 296. On the men's side, it was 27 to 251. Okay, our 95% confidence interval, and then make sure to change your type of test to the alternative hypothesis, which is that P1 does not equal P2. And then all of our information for the next few problems will be found down here in the bottom. So the test statistic is the z, which is found right here, 3.309. Part D, compute the p-value. Remember, for the p-value, we take our z-score, the 3.309, and input it into our probability applet. So we come over to our probability applet, type in 3.309. We get a p-value of 0.0004. Okay, and that is Part D. Part E, shade your p-value on the normal distribution curve with the test statistic labeled. Okay, so just label your z test statistic and then take a picture of this graph right here. F, what decision do you make about the null hypothesis? We reject the null because our p-value is less than our level of significance. G, state your conclusion in layman's term. We have sufficient evidence because we rejected the null, to say that there is a difference in the proportion of men who use labels and women who use labels. And then that second part is just a restatement of the alternative hypothesis. Question 5, construct a 95% confidence interval for the difference of the proportions in question 4. Okay, so we'll come back to the Excel. And the proportion, or the confidence interval, is right here in the bottom, in the middle section of the bottom. It says confidence interval for P1 minus P2. So it's from 0.044 to 0.16165. Question 6. Interpret the confidence interval you constructed in question 5. So we can say that with this confidence interval, that we are 95% confident that the true difference between the proportion of men being label users and women being label users, and this is talking about the entire population, not just from the sample, but now we're going to expand this to the whole population. We can say we're 95% confident that it's between 0.044 and 0.165.